Hello students. So in this video, we'd like to go through the solution for assignment 3.1, okay, on matrices. So this is the first question that I ask you to try. So this is a straightforward um, question involving the addition and subtraction of a matrix, right? So the first thing we need to do when we are asked to add or subtract matrix is to check that the order is the same. So in this case, all the matrices are fine. They all have 3 rows and 2 columns, right? So it's a 3 by 2. So we can actually do this, right? So what we need to do is make sure that every number in every element in its position is computed separately. So in the top left corner over here, we start with -4 minus -1, right? Then we plus -1. So from there, we work it out, it's actually -4 in the top left corner. So we repeat this for every position, right? So now it's the second one, second row, first column. So -1 minus -2 plus 0, we have 1, and so on and so forth. Okay, so we complete the entire computation, which will take a while, right? But important thing is when you are pressing the buttons on your calculator, do it carefully and you should be fine. So you obtain this. So this is the final result. -4, 1, and -1 on the first column, 1, 1, and -2 on the second column. Okay. Now, the next question, slightly more challenging, or rather increase the complexity a little bit because we have a little multiplier outside the matrix, right? So in this case, this is a 1 row by 3 column matrix. So 1 by 3, 1 by 3. We can add them together, but we need to take note of the multiplier. So there's additional steps that we need to do, right? So the multiplier outside the matrix here, so scalar multiplication, so it can be distributed to every element inside. So in this case, 2 multiply into the matrix, we have 6, -4, and 8. Over here, 3 multiply in, you get 3, 12, and 21. And then, of course, accordingly, you have 6 plus 3, 9, -4 plus 12, 8, and 8 plus 21, 29 over here. Okay, so just one more extra step that you need to do when you have a scalar multiplication. Okay, the next question, again, just another practice, this time round with the scalar multiplication, but just to make things a little bit more interesting, this one has a fraction, so we multiply by half. The procedure is exactly the same, right? So we multiply, distribute the half in, we get 4, -2, 2, and 3 over here. And over here, when we multiply 2 in, you get -12, 8, 2, and 4. Then after that, do our subtraction, 4 minus -12, 16. 2 minus 8, we have -6 here. -2 minus 2, -4. 3 minus 4, -1. Okay. So far, I hope you're having success with all these questions. They are quite straightforward computation. The next question, things gets a little bit more interesting, right? So the next one, we have some unknowns in the matrix, and just like we add and subtract variables when we are doing algebra, the same thing applies here. So if you know what you're doing, it's not frightening, right? So again, a quick check, all the matrices are 2 by 2, so it's fine. So and then we have multipliers, right? So we can multiply it in first, so the 2 will actually be distributed in. We have 10y, 2, 16, 8, 8x over here. Okay, over here the quarter will go in, so 10 over 4, 1, 1/4, 2. So there's fractions. Okay, don't panic, we know what to do with fractions. You know how to use the calculator, so just type in the fractions accordingly, right? So down here will be 1y plus 10y, so 11y, minus 10 over 4y, so we have 8.5y or 8.5y. Okay, then on the bottom, okay, first second row, first column, 3 plus 16 minus 1/4, 18.75, or you can write it as 18 3/4. It's fine as long as you write it clearly enough, right? So we have a 0 plus 2 minus 1, so it's 1 over here. And x plus 8x, 9x, right? 9x minus 2x, we get 7x over here. Okay, so even with variables, the procedure is the same. So this question just want to throw in some variable to make things a little bit more exciting. But we know what's what, right? So that's fine. Okay, moving on. The next question, this one, again, there's some variables inside there. Okay, however, this time round, because this is an equation, okay, so we now can solve this, right? So how do we solve this? We have 8 x plus, okay, down here 2 times 3, right? So it becomes 6 over here, right? Equals to 11. Then 2y plus 2 times 1 is 2 equals to x. So what's the situation here? Okay, this is actually a pair of simultaneous equation. Okay, and you did learn simultaneous equation not too long ago. So it's actually x plus 6 equals to 11. That gives us the first equation. Then 2y plus 2 equals to x, it gives us a second equation. From equation 1, because there's only one variable x in equation 1, so very quickly we obtain the value x equals to 5 over here. And then we substitute that into equation 2, and we get y equals to 1.5. Okay, nothing too crazy over here. So I hope you're successful with this. Okay. Next question, question 8. This is a question I ask you to try. Another practice, making use of the idea, okay, of simultaneous equation, right? So when we work out matrix like this, sometimes no simultaneous equation is formed, and we have already practiced doing simultaneous equation quite a bit previously. So let's do this, right? So x, 2x over here. So x plus 2y equals to 7. So x plus 2y equals 7 over here. 2x plus 6y equals to 20. We can write it this way. Then we can compare the top value to the top value, bottom value to bottom value. Write it out. Equation 1, equation 2. And for this particular case, feel free to use substitution method if you want, but I did the elimination method here. So I take the first equation, multiply by 2, so 2x, right, times 2, 2x, 2y become 4y, 7 become 14, equation 3. Now I have 2x over here on equation 2, 2x over here in equation 3. I can eliminate it by subtracting one equation with another. So equation 2 minus equation 3, so 2x minus 2x is gone, right? 6y minus 4y, we get 2y. 20 minus 14, we get 6. So very quickly, y equals to 3. Now, as with all attempts to solve simultaneous equation, I have to remind you, after we find y, please remember to go back and find x, right? So I substitute y equals to 3 back into equation 1 over here. You can substitute into 2 or 3, doesn't matter, right? So we have x plus 2y. Okay, replace the y with 3 equals to 7. You work it out, x equals to 1. And then finally, you can actually write it down in the final conclusion. X equals to 1, where y equals to 3. Okay. One final practice for this assignment is this one. Okay. So over here, what happened is we throw in some quadratic just to have some fun, right? So again, quick check. This is a 1 row by 2 column, 1 row by 2 column, 1 row by 2 column. It works. Okay. So over here, x squared here will be subtracting 5x to form the first value. 4y squared minus 2y will form the second value. So from here, you can actually equate them separately. So x squared minus 5x, right? The first number here equals to 0. So if we factorize this becomes x times x minus 5 equals to 0. Using the zero product principle, we know that either the x is equals to 0 or x minus 5 equals to 0. And if x minus 5 equals to 0, it means x equals to 5. So these are the two possible solutions for x. Over here, using the same idea, okay, we have 4y squared minus 2y. If we factorize it, this is what we have. So 2y is equals to 0, or 2y minus 1 equals to 0. So if 2y is equals to 0, it simply means y equals to 0, because, well, 0 divided by 2 gives us 0, right? And over here, 2y minus 1 equals to 0 means y is equals to half, right? Because 2 times half minus 1 gives us 0. And that is the final question that I asked you to try for this assignment. I hope you're successful. If not, well, complete your corrections and learn from the corrections. Okay, have a nice day.